After more than 12 years studying Saturn, its rings and moons, NASA's Cassini spacecraft entered the final tasks of its epic voyage. The analysis of the historic scientific odyssey will continue for years, long after the spacecraft completed its endgame. A few years since Cassini's final days, and the insights are still puzzling, numerous, and exciting. Let's take a look at over a decade of historic research on the most exuberant planet of the solar system, Saturn. The penultimate mission phase started on November 30th, 2016, with a series of ring-grazing orbits. These orbits, a series of 20, are called the F-ring orbits. During these weekly orbits, Cassini will approach to within 4,850 miles, or 7,800 kilometers, of the center of the narrow F-ring, with its peculiar kinked and braided structure. The last time we got this close to the rings was during arrival at Saturn in 2004, and we saw only their backlit side. Now we have dozens of opportunities to examine their structure at extremely high resolution on both sides, said Linda Spilker, Cassini project scientist at NASA's Jet Propulsion Laboratory, Pasadena, California. The last act, a grand finale. Cassini's final phase, called the grand finale, began in earnest in April 2017. A close flyby of Saturn's giant moon, Titan, reshaped the spacecraft's orbit so that it passed through the gap between Saturn and the rings, an unexplored space only about 1,500 miles or 2,400 kilometers wide. The spacecraft has made 22 plunges through this gap, beginning with its first dive on April 27th. It's like getting a whole new mission. The scientific value of the F-ring and grand finale orbits is so compelling that you could imagine a whole mission to Saturn designed around what we're about to do. Linda Spilker, Cassini project scientist. During the grand finale, Cassini made the closest ever observations of Saturn, mapping the planet's magnetic and gravity fields with exquisite precision and returning ultra-close views of the atmosphere. Scientists gained new insights into Saturn's interior structure, the precise length of a Saturn day, and the total mass of the rings, which may finally help settle the question of their age. The spacecraft analyzed dust-sized particles in the main rings and sampled the outer reaches of Saturn's atmosphere, both first-time measurements for the mission. It's like getting a whole new mission, said Spilker. The scientific value of the F-ring and grand finale orbits is so compelling that you could imagine a whole mission to Saturn designed around what we're about to do. Getting inside Saturn, literally. Since the beginning of 2016, mission engineers had been tweaking Cassini's orbital path around Saturn to position the spacecraft for the mission's final phase. They have sent the spacecraft on a series of flybys past Titan that are progressively raising the tilt of Cassini's orbit with respect to Saturn's equator and rings. This orientation enabled the spacecraft to leap over the rings with a single and final Titan flyby in April to begin the grand finale. We've used Titan's gravity throughout the mission to sling Cassini around the Saturn system, said Earl Mays, Cassini project manager at JPL. Now, Titan is coming through for us once again, providing a way for Cassini to get into these completely unexplored regions so close to the planet. The grand finale came to a dramatic end on September 15, 2017, as Cassini dove into Saturn's atmosphere, returning data about the planet's chemical composition until its signal is lost. Friction with the atmosphere caused the spacecraft to burn up like a meteor soon afterward. Let us take a look at how the Cassini mission all began. Before this spacecraft came several flybys of Saturn by Pioneer 11 in 1979, Voyager 1 in 1980, and Voyager 2 in 1981. Some of the discoveries that came out of these missions included finding out that Titan's surface can't be seen in visible wavelengths due to its thick atmosphere, and spotting several rings of Saturn that were not visible with ground-based telescopes. It was shortly after the last flyby in 1982 that scientific committees in both the United States and Europe formed a working group to discuss possible future collaborations. The group suggested a flagship mission that would orbit Saturn and would send an atmospheric probe into Titan. However, there was a difficult fiscal climate in the early 1980s. NASA's Jet Propulsion Laboratory noted in a brief history of the mission, which pushed approval of Cassini to 1989. The Europeans and Americans each considered either working together or working solo. A 1987 report by former astronaut Sally Ride, for example, advocated for a solo mission to Saturn, called NASA's Leadership and America's Future in Space. The report said that studying the outer gas giant planets such as Saturn helps scientists learn about their atmospheres and internal structure. Today, we also know that this kind of study helps us predict the structure of exoplanets, but the first exoplanets were not discovered until the early 1990s. Titan is an especially interesting target for exploration because the organic chemistry now taking place there provides the only planetary-scale laboratory for studying processes that may have been important in the prebiotic terrestrial atmosphere, the reporter added, meaning that on Titan is chemistry that could have been similar to what was present on Earth before life arose. Cassini's development came with at least two major challenges to proceeding. By 1993 and 1994, the mission had a $3.3 billion price tag, roughly $5 billion in 2017 dollars, or about half the cost of the James Webb Space Telescope. Some critics perceived this as overly high for the mission. In response, NASA pointed out that the European Space Agency was also contributing funds and added that the technologies from Cassini were helping to fund lower-cost NASA missions such as the Mars Global Surveyor, Mars Pathfinder, and the Spitzer Space Telescope, according to JPL. Cassini also received flack from environmental groups who were concerned that when the spacecraft flew by Earth, its radioisotope thermoelectric generator, nuclear power, could pose a threat to our planet, JPL added. These groups filed a legal challenge in Hawaii shortly before launch in 1997, but the challenge was rejected by the Federal District Court in Hawaii and the Ninth Circuit Court of Appeals. To address concerns about the spacecraft's radioisotope thermoelectric generators, which are commonly used for NASA missions, NASA responded by issuing a supplementary document about the flyby and detailing the agency's methodology for protecting the planet, saying there was less than a 1 in a million chance of an impact occurring. Cassini didn't head straight to Saturn. Rather, its mission involved complicated orbital mechanics. It went past several planets, including Venus twice, Earth, and Jupiter, to get a speed boost by taking advantage of each planet's gravity. The nearby 12,600-pound, about 5,700 kilograms, spacecraft was hefted off Earth on October 15, 1997. It went by Venus in April 1998 and June 1999, Earth in August 1999, and Jupiter in December 2000. Cassini settled into orbit around Saturn on July 1, 2004. Among its prime objectives were to look for more moons, to figure out what caused Saturn's rings and the colors in the rings, and understanding more about the planet's moons. Perhaps Cassini's most detailed look came after releasing the Huygens lander toward Titan, Saturn's largest moon. The lander was named for Dutch scientist Christian Huygens, who in 1654 turned a telescope toward Saturn and observed that its odd bulb-like shape. Galileo Galilei had first seen the shape in a telescope and drew it in his notebook as something like ears on the planet was in fact caused by rings. The Huygens lander descended through the mysterious haze surrounding the moon and landed on January 14, 2005. It beamed information back to Earth for nearly 2.5 hours during its descent, and then continued to relay what it was seeing from the surface for 1 hour and 12 minutes. In that brief window of time, researchers saw pictures of a rock field and got information back about the moon's wind and gases on the atmosphere and the surface. Magnificent moons. One of the defining features of Saturn is its number of moons. Excluding the trillions of tons of little rocks that make up its rings, Saturn has 62 discovered moons as of September 2012. NASA lists 53 named moons on one of its websites. In fact, Cassini discovered 2 new moons almost immediately after arriving, Methone and Pallene. And before 2004 had ended, it detected Polydeuces. Gallery latest Saturn photos from NASA's Cassini orbiter. As the probe wandered past Saturn's moons, the findings it sent back to Earth revealed new things about their environments and appearances. Some of the more notable findings include finding evidence of liquid water on Enceladus, a frozen moon that shoots out icy jets as it is warped by Saturn's gravity. In 2015, Cassini did a series of flybys of Enceladus to get more information about the gas and dust in the plumes. Discovering and then pinning down more details about a giant methane lake on Titan, 50-mile landscapes on Iapetus, a close-up view of Rhea revealing a pockmarked surface, a huge ring 8 million miles away from Saturn, likely made up of debris from Phoebe. Saturn has not gone ignored either. For example, in 2012, a NASA study postulated that Saturn's jet streams in the atmosphere may be powered by internal heat instead of gravity from the sun. Scientists believe that heat brings up water vapor from the inside of the planet, which condenses as it rises and produces heat. That heat is believed to be behind jet stream formation, as well as that of storms. Cassini was originally slated to last 4 years at Saturn, until 2008, but its mission has been extended multiple times. Its last and final leg was called the Cassini Solstice Mission, named because the planet and its moons reached the solstice again toward the mission end. Saturn orbits the Sun every 29 Earth years, with Cassini's mission lasting 13 years. This meant that the spacecraft observed almost half of Saturn's seasonal change as the planet went around its orbit. In 2016, the spacecraft was set on a series of final maneuvers to provide close-up views of the rings, with the ultimate goal of plunging Cassini into Saturn on September 15, 2017. This strategy was designed to protect Enceladus and other potentially habitable moons from the small chance of Cassini colliding with the surface, spreading Earth microbes. Major milestones of the finale included ring-grazing orbits. Every week between November 30th, 2016 and April 22nd, 2017, Cassini did loops around Saturn's poles to look at the outer edge of the rings, to learn more about their particles, gases, and structure. It also observed small moons in this region, including Atlas, Daphnis, Pan, and Pandora. On April 22, 2017, Cassini made the final flyby of Titan. The flyby was done in such a way to change Cassini's orbit so that it began 22 dives, once a week, between the planet and its rings. This was the first time any spacecraft explored this zone, and it entailed some risk because the orbit brought it between the outer part of the atmosphere and the inner zone of the rings, where it is at risk of striking particles or gas molecules. On September 15, 2017, Cassini made a plunge into Saturn, taking measurements for as long as its instruments could make communications back to Earth. Some of the science Cassini performed during this period included creating maps of the planet's gravity and magnetic fields, estimating how much material is in the rings, and taking high-resolution images of Saturn and its rings from close up. The spacecraft made an interesting discovery from its new vantage point. It found that Saturn's magnetic field is closely aligned with the planet's axis of rotation, which baffled scientists because of how they think magnetic fields are generated, through a difference of tilt between the magnetic field and the planet's rotation. As of late July 2017, however, scientists plan to gather more data to see if perhaps Saturn's internal processes confused their measurements. Shortly after the spacecraft's demise, Cassini mission planner Eric Storm told reporters he planned to write a report about what he and his team learned after operating a mission for such a long time. While enthusiasm kept the scientists going through the long years, which sometimes required working during the holidays or in the middle of the night, engineering was also key. Kim Stedman, an engineer on the Cassini team for 14 years, said that redundancy was essential. She said that a reaction wheel and some of the probe's thrusters failed during the mission, which would have meant that the spacecraft couldn't point its instruments to collect data or communicate with Earth through pointing its antenna at the planet. However, Cassini's mission continued because it had backups. The team plans to issue the report to help with future spacecraft planning. One of those recommendations might be including a gas gauge. Cassini died with about 1% of its fuel left, but lead propulsion engineer Todd Barker told Space.com that he had a tough time estimating how much fuel was left in Cassini. He had to do so through various indirect methods. This meant that during the final months, Barber was slightly nervous about maneuvers requiring propulsion, since there was a margin of error for his calculations and didn't know if there was enough fuel remaining to carry them out. The mission may be over, but science results will continue to flow for decades because not all of the information has been analyzed yet. NASA also continued to release new photos from the spacecraft, even after Cassini had died. In late September 2017, for example, the agency sent out a photo of Enceladus, a target of high interest due to the many geysers on the moon's surface. There are also several other early-stage missions in the works to fly to Saturn. While these missions are years away, if they are ever approved, they represent scientific interest in Saturn and its moons, and their design is based on Cassini's discoveries. Specifically, 5 Saturn-related concepts are contending for the next New Frontiers missions, a program that in past years yielded the New Horizons Pluto spacecraft, the Juno-Jupiter orbiter, and the asteroid return spacecraft, OSIRIS-REx. The 5 proposals are Sprite, Saturn Probe Interior and Atmosphere Explorer, which would deliberately fly into Saturn's atmosphere to look at its composition and structure for roughly 90 minutes. Cassini lasted only a couple of minutes during its plunge, but it was not designed for this work. Oceanus, which is designed to look at Titan's potential for habitability by examining organic molecules through the methanologic cycle and assessing exchange processes between the atmosphere, surface, and subsurface. according to project description presented at the 48th Lunar and Planetary Science Conference in the Woodlands, Texas. Dragonfly, which would make periodic flights in Titan's atmosphere to look at organics on its surface in several locations. Enceladus Life Finder, which would fly through plumes multiple times to collect and characterize the molecules that are there, particularly complex organic compounds that could indicate precursors of life. Enceladus Life Signatures and Habitability, of which little has been released publicly. It may be targeting the plumes of Enceladus, which were examined periodically by Cassini during flybys. The winning candidate among the 12 proposed New Frontier missions, the other missions target Venus, the Moon, or comets, will be selected in mid-2019 for launch no later than 2025. However, there is a semi-final selection. NASA will select 2 or 3 of these proposals before then for further study ahead of making the final decision. NASA's robotic Cassini spacecraft burned up, ending a remarkable 13-year run at Saturn that has revolutionized scientists' understanding of the outer solar system and its potential to host life. Why does NASA want to end the research? Is there more research to be done? What did we learn from this majestic ringed giant planet? Well, Cassini discovered methane seas on Saturn's huge moon, Titan, and geysers of water vapor blasting from fellow moon Enceladus. Both of these moons are worthy of much further study, as is the ringed planet itself and the diverse Saturn system as a whole, Cassini team members said. We left the world informed, but still wondering, and I couldn't ask for more. Cassini project manager Earl Mays of NASA's Jet Propulsion Laboratory in Pasadena, California said during a news conference Wednesday, September 13th, "We've got to go back. We know it." And various research teams are indeed working on plans to return to Saturn. In fact, 5 such concepts are in the running for NASA's next New Frontiers mission, the same type flown by the agency's New Horizons Pluto probe, Juno-Jupiter orbiter, and OSIRIS-REx asteroid sample return craft. Saturn's atmosphere. During its intentional death dive Friday, Cassini briefly became the first ever Saturn atmospheric probe. One of the proposed New Frontiers missions would pick up on and greatly extend the last measurements Cassini ever made. The Sprite, Saturn probe interior and atmosphere explorer spacecraft, would plunge into Saturn's thick atmosphere, characterizing its composition and structure for about 90 minutes before breaking apart and burning up. Cassini, which was not built for such work, lasted just a minute or 2 during its dive. Fundamental measures of the interior structure and noble gas abundances of Saturn are needed to better constrain models of solar system formation, as well as to provide an improved context for exoplanet systems. Principal investigator Amy Simon of NASA's Goddard Space Flight Center in Greenbelt, Maryland, and her colleagues wrote in a mission description last year. Sprite would make such measurements, and its data would help ground truth data Cassini gathered about Saturn from afar over the years, the scientists added. Latest Saturn photos from NASA's Cassini orbiter. Studying Titan. Cassini studied Titan closely over the course of 127 targeted flybys. The Saturn orbiter also carried a piggyback European lander called Huygens, which touched down on the 3,200-mile-wide, 5,150 kilometers moon in January 2005. In the process, it became the first probe ever to pull off a soft landing on a body in the outer solar system. Observations by both Cassini and Huygens revealed Titan in all its otherworldly glory. Hydrocarbon rain falls from the huge moon's sky, pooling in the lakes and seas of methane, some of which are as big as Earth's Black Sea. complex organic chemicals, the carbon containing building blocks of life as we know it, waft about in Titan's thick, nitrogen-dominated atmosphere and eventually drifts down to the moon's surface. It's possible that this bizarre landscape could harbor life, astrobiologists say, and Cassini's work suggests that the big moon may have another potentially habitable environment as well, a salty ocean of liquid water buried beneath the crust. Indeed, Cassini was directed to its doom primarily to ensure that it would never contaminate Titan or Enceladus with microbes from Earth. A proposed New Frontiers mission called Oceanus would investigate both of these environments, taking a variety of measurements from its perch in orbit around Titan. For example, the probe would characterize the organics in the moon's atmosphere and help researchers determine how thick and rigid Titan's crust is and whether it is convecting internal heat to the surface. Oceanus would follow up on Cassini's amazing discoveries and assess Titan's habitability by following the organics through the methanologic cycle and assessing exchange processes between the atmosphere, surface, and subsurface. The concept mission's planners wrote in a description of the project, which they presented earlier this year at the 48th Lunar and Planetary Science Conference in the Woodlands, Texas. Also in the New Frontiers running is Titan Dragonfly, which would send a drone to study the moon from the air and ground. Heavier than air flight is substantially easier on Titan than on Earth. Dragonfly principal investigator Elizabeth Turtle, a planetary scientist at the Johns Hopkins University Applied Research Laboratory in Maryland, told Space.com earlier this year. Titan's atmosphere is considerably thicker than that of Earth, but the moon's gravity is just 14% as strong as our planet's. That means we can take a really capable lander and move it by a few tens of kilometers in a single flight and hundreds of kilometers over the time of the mission, Turtle added. The drone would study the composition of Titan's organics in detail at a variety of different locations. Dragonfly is a truly revolutionary concept, providing the capability to explore diverse locations, to characterize the habitability of Titan's environment, investigate how far prebiotic chemistry has progressed, and search for chemical signatures indicative of water-based and/or hydrocarbon-based life. Turtle and her colleagues wrote about the potential mission in their presentation at the 48th Lunar and Planetary Science Conference. Amazing photos, Titan, Saturn's largest moon. The plumes of Enceladus. The other two Saturn-oriented New Frontiers proposals target 313-mile-wide, 5,004-kilometer Enceladus, whose geysers were a revelation to the Cassini team, NASA officials, and space scientists in general. When we observed the southern hemisphere of Enceladus and geysers of water spewing out into the Saturn system, it amazed us and began changing the way we view the habitability or potential habitability of moons in the outer part of our solar system. Jim Green, chief of NASA's Planetary Science Division at the agency's headquarters in Washington, D.C., said at Wednesday's news conference. That's because the water in Enceladus's geysers is apparently coming from an ocean of liquid water that sloshes beneath the frigid moon's icy crust. Cassini observations suggest that this ocean may even have a chemical energy source that could support life as we know it. But researchers want to learn more about the ocean, and the geysers' plume provides a great way of doing so. One of the New Frontiers candidates, known as Enceladus Life Finder, ELF, would zoom through this plume repeatedly, collecting and analyzing molecules. ELF would look for complex organic compounds that could be a sign of prebiotic chemistry, or perhaps even of life itself. It's free samples, principal investigator Jonathan Lunine of Cornell University told Space.com in 2015 when ELF was competing for a slot in NASA's Discovery program of low-cost, extremely focused missions. In January of this year, NASA chose the Asteroid Studying Lucy and Psyche missions as its next Discovery projects. We don't need to land, drill, melt, or do anything like that. Cassini did some plume samples of its own, but ELF would sport more sensitive mass spectrometers than its predecessor did, ELF team members have said. Cassini's handlers didn't know about Enceladus's geysers before launch, so they didn't put any life-hunting gear aboard the craft. Not much has been publicly revealed about the final Saturn-oriented New Frontiers proposal, but its name, Enceladus Life Signatures and Habitability, suggests that it would also be a plume sampling mission. You can learn more about all 12 New Frontiers candidates, the other 7 of which would target Venus, a comet, or Earth's moon, in this excellent synopsis by the Planetary Society's Van Kale. Will any of them fly? NASA is expected to cull the New Frontiers proposals to a handful of finalists before the end of the year and announce the selected mission sometime in 2019. That mission will have a cost cap of $850 million, excluding launch, and will lift off by 2025. So it's too soon to say if any of the Saturn-centric missions will ever get off the ground. But fans of the ringed planet may be heartened by one of Green's comments at a news conference. Cassini's discoveries will live on for many decades afterwards, and already they're beckoning us to go back, Green said. Between NASA's Voyager mission, which visited Saturn with back-to-back flybys in 1980 and 1981, and Cassini was 30 years, he said, and I believe that will be much shorter the next time around. For more than a decade, NASA's Cassini spacecraft shared the wonders of Saturn and its family of icy moons, taking us to astounding worlds where methane rivers run to a methane sea, and where jets of ice and gas are blasting material into space from a liquid water ocean that might harbor the ingredients for life. Cassini revealed in great detail the true wonders of Saturn, a great world ruled by raging storms and delicate harmonies of gravity. Cassini carried a passenger to the Saturn system, the European Huygens probe, the first human-made object to land on a world in the distant outer solar system. After 20 years in space, 13 of those years exploring Saturn, Cassini exhausted its fuel supply. And so, to protect moons of Saturn that could have conditions suitable for life, which is why Cassini was sent on a daring final mission that would seal its fate. What's next? Before the mission ended, Cassini's was an already powerful influence on future exploration, in revealing that Enceladus has essentially all the ingredients needed for life. The mission energized a pivot to the exploration of ocean worlds that has been sweeping planetary science over the past couple of decades. Lessons learned during Cassini's missions are being applied in planning NASA's Europa Clipper mission, planned for launch in the 2020s. Europa Clipper will make dozens of flybys of Jupiter's ocean moon to investigate its possible habitability using an orbital tour design derived from the way Cassini explored Saturn. Further out in the solar system, scientists have long had their eyes set on exploring Uranus and Neptune. So far, each of these worlds has been visited by only one brief spacecraft flyby, Voyager 2 in 1986 and 1989 respectively. Collectively, Uranus and Neptune are referred to as ice giant planets. A variety of potential mission concepts are discussed in a recently completed study delivered to NASA in preparation for the next decadal survey, including orbiters, flybys, and probes that would dive into Uranus's atmosphere to study its composition. Further missions to the ice giants might explore those worlds using an approach similar to Cassini's mission. Cassini's spacecraft and its legacy is a powerful influence on future exploration. In revealing that Enceladus has essentially all the ingredients needed for life, the mission energized a pivot to the exploration of ocean worlds that has been sweeping planetary science over the past couple of decades. Jupiter's moon, Europa, has been a prime target for future exploration since NASA's Galileo mission in the late 1990s found strong evidence for a salty global ocean of liquid water beneath its icy crust. But the revelation that a much smaller moon, like Enceladus, could also have not only liquid water but chemical energy that could potentially power biology was staggering. Many lessons learned during Cassini's mission are being applied in planning NASA's Europa Clipper mission, planned for launch in the 2020s. Europa Clipper will make dozens of flybys of Jupiter's ocean moon to investigate its possible habitability using an orbiter tour design derived from the way Cassini explored Saturn. The mission will orbit the giant planet, Jupiter in this case, using gravitational assists from large moons to maneuver the spacecraft into repeated close encounters, much as Cassini used the gravity of Titan to continually shape the spacecraft's course.